Solving quadratic equations. There are two different methods of solving quadratic equations that you learned in previous math courses, by factoring and by using the quadratic formula. Today we'll be looking first at solving by factoring, and tomorrow will be the quadratic formula. Now, in order to solve quadratic equations by factoring, we have to remember the zero product property, and we talked about this with rational expressions and finding restrictions. Remember, if a times b is equal to 0, then either a is equal to 0 or b is equal to 0, or they both could be 0. That's the only way that you can multiply two numbers and get 0. So to solve a quadratic equation by factoring, we want to use that trick right there. So the first step will be to rearrange the equation so that you have a standard form quadratic equation on one side and just 0 on the other. Then we will factor fully. We'll factor this quadratic expression fully, and because it's equal to 0, we'll be able to find the values of the variable that will make each binomial equal to 0, just like when we found restrictions in the previous unit. So as an example here, I have negative 2b squared minus 8 is equal to negative 3b squared minus 2b. So I'd like to know the values of b, which would satisfy this equation. And when I say satisfy the equation, I mean that the left side would have to be equal to the right side. So like I said, I want to have everything on one side with just 0 on the other. So it doesn't matter what side you put 0, typically we'd put it on the right hand side. So if I move these two terms over, I'd have to add 3b squared to this side, so negative 2b squared plus 3b, so if I move that over, I'd be left with b squared, minus 2b. When I move that over, I'd have to add 2b, so plus 2b. There's no term with a b on this side, and then I just have minus 8. Okay, so no other terms to move over. I've moved everything over to this side, and it's equal to 0. At this point, I can factor. Now, this is a simple trinomial, and I'm not going to spend much time talking about factoring here. We should know how to do this, but this is what it factors into. B plus 4 times b minus 2 is equal to 0. Alright, so now what we have is we have two binomials, b plus 4 being one of them, is being multiplied by b minus 2, and we somehow get 0 out of that. So that means either this first binomial would have to be 0, and the value of b that would give us that is negative 4, or this binomial could be 0, which would give us an answer of b equals positive 2. So those are two different values of b which would satisfy this equation, and you can check your answer by, for example, substituting in b equals 2. You should get the same value on the left hand side that you do on the right hand side. Same thing with b equals negative 4, substituting those in for b, you should get the same value on the left side and on the right. This question here will be solved using factoring, but I want to go over now just how we can set up our equation. This is a word problem, so an application type problem. We'll finish off the solution in class, but I want to set up the equation right now. So a rectangular garden measures 6 meters by 4 meters. So this is the inside rectangle that I have, measures 6 meters by 4 meters. And there's also a walkway around it. So think of a sidewalk all the way around with a width of w surrounds the whole garden. So this width right here would be w, this would be w, and so on. We can also call this a uniform width. What uniform means is that it's the same everywhere. So if you have a school uniform, everyone's wearing the same thing. Uniform width is the width is the same all the way around. Now, the total area of the property is 48 meters squared. So the entire property is actually this entire distance right here. Okay, and obviously area is the inside. We want to know how wide the walkway would have to be to achieve that. Now, remembering that the area formula, we have a rectangle here, is length times width. Now, we know that the area is 48 meters squared. What we really don't know is the length of this and the width. So we have to come up with expressions actually. It's going to be two binomials for the length and for the width. So So for the length, if I highlight in different color here, this area, or sorry, this length here is 6 meters, but that's only of the garden. We also have this length right here, which is width W, and this length, which is width W. So the length does have at least 6 meters, but it also has W plus W, which is 2W. So 2W plus 6 is the entire length of the property. Using that same idea, so 4 meters is the width, so it does have at least 4 meters, but it also has a width W on one side and a width W on the other side, so that would be 2W plus 4. So this is the equation that we're going to be dealing with. At this point, we have to make it look like a quadratic expression in standard form with all the terms on one side. So this right now is factored on this side. We actually have to expand that out and also bring the 48 over there so that we have everything on one side fully expanded. So I'm going to pause this and expand this side very quickly. So that's just expanding using FOIL. We know how to do that already, that's why I skipped it. So if I want to solve this equation by factoring to find out what W would have to be, I now also have to have the 48 on that side so that I have just 0 on one side. Again, the 0 can be on either side, it doesn't really matter. So I'll have 4W squared plus 20W. I have plus 24, but I'd have to subtract 48 to move that over, so that'll be minus 24. At this point, I could factor this and then solve for the values of W, but I will wait until we're in class to finish that off.